Hi everyone. So here are the solutions to those mechanics problems that I sent you guys. I'm not going to do them all because some of them are not relevant to you guys in terms of the difficulty you need for this exam. So I'll tell you which ones they are, and I'll only solve those ones. So here's the first one. It's the same one we did in class. I'm going to do it over again so that everyone can follow it at home. So here we have an object. This is number one. And I'll scan and email these again later as well, so you'll have a chance to look at them once I'm done. So we have an object, which I failed to give you the mass of, but I'll give it to you right now. It's 10 kilograms. And you exert a force of 200 newtons on it. So the force applied here is equal to 200 newtons. You have the force of gravity downwards, the force of the normal upwards, and at this moment when I'm drawing this picture, this object is at rest. So there is no it's not in motion, and therefore there's a force of static friction, and the coefficient is 0.01, and that's all we know so far. So I'm going to go ahead and tell you a little bit about how I solved the problem. It says here, if the coefficient of kinetic friction is 0.05, how far does the object move? How far does the object travel before it comes to a stop? So essentially what's happening is I'm giving a nudge to this object, and it's going to roll down or slide down or whatever a street, and it's eventually going to come to a stop because of the friction underneath it. Now, in order for me to find out with what velocity it's going to need to slow down, I have to take into account how fast I make it move using my own applied force, and that's what this is about. So let's figure out what this friction force is. So I have the force of gravity, and the force of the normal, I have the force of friction, and I have the force applied. I know the force applied is 200 newtons. I know that the force of gravity is mass times acceleration, so 10 kilograms times 9.8, which is equal to 98 newtons, and that's in the negative direction because it's going down. And the normal force is the opposite of that, so it's plus 98. There are no other forces on the x and y, and overall, there are no other forces on the y, and overall my force on the y is 0. My gravitational force and my normal force don't have an x component, and my friction force can be expressed using the normal force. So it's mu times Fn, and that's equal to 0.01 times 98, and that's equal to 0.98 newtons. Alright? And that's in the negative direction. It's working against my applied force. So my total force is this plus this, which gives me about 199 newtons. Alright? And now the acceleration that I'm applying onto the object is equal to, force is equal to the total force is equal to the mass times the acceleration, the total acceleration. And the total acceleration is 199 newtons is equal to 10 kilograms times some acceleration, and therefore I can figure out what my acceleration is, and that is 19.9 meters per second squared. That's my acceleration. Perfect. Now, it says I pushed the object for 0.5 seconds, right? So if I know that this is an acceleration, so I can do acceleration is equal to delta v over delta t, and therefore it's equal to initial final minus initial. So whatever my final velocity is minus my initial velocity, which is 0 meters per second, divided by 0.5 seconds, and that's equal to. My acceleration is equal to 19.99. That's equal to 9.8 meters per second is equal to Vf. Alright, so once I start pushing it, my object has a velocity of 9.8 meters per second. Now I want to know how long is it going to take for this to come, this object that's moving at 9.8 meters per second, for that to come at a stop. Now I stopped applying a force on it, so there's no more 200 newtons on this. I stopped pushing. Alright, so the only force now acting on it is the kinetic friction. So we can draw another free body diagram. Alright, here we go, up and down. And now there's only friction, and that's kinetic friction. Right? There's no more force applied going in this. There's no more force applied going in this direction. So the normal force in this case, I'm just going to borrow it from before, is 98 newtons, and in the down direction is minus 98 newtons. And the force of kinetic friction is equal to 0.005, because it's given in the question, times the normal force, which is 98 newtons. And that's equal to, so force of friction is equal to 0.49 newtons. Alright, so this is the force, the overall force that's acting on my object. If I wanted to do an x and y for this, just so that everyone's comfortable, so I have the force of the normal, force of gravity, the force of friction. And the force of normal is 98 newtons. Gravity is negative 98 newtons. Friction has no y component, and my overall has no y component. Normal force has no x component, gravitational force has no x component, and the force of friction has a negative 0.49 newtons, which gives me a total of 0.49 newtons. Right? And therefore I can calculate what the overall acceleration is. So 0.49 newtons equals 10 kilograms times acceleration. And therefore my acceleration is 0.05 meters per second squared. Negative, because this is a negative, is equal to acceleration. Alright. Now I want to see how far this object goes. It's traveling at, so the VO is equal to 9.8 meters per second. The acceleration is equal to negative 0.05 meters per second squared, and I want to find what my final distance is. I want to find out what the distance is after my object has stopped. So my object stops when it's going at 0 meters per second. And I want to figure out how far it goes. So I can use the formula, Vf squared is equal to Vo squared plus 2AD. Okay? So 0 meters per second squared is equal to 9.8 meters per second squared. All that squared, all this squared is equal plus 2 times negative 0.05 meters per second squared. These don't have squares. Times delta D. And delta D, if I do the algebra, is equal to delta D is equal to 960 meters. Alright, so this was a really slick surface. Alright? Long problem, but the difficulty shouldn't be too hard once you understand the concepts. Alright. Question 2. 70-kilogram man falls out of a burning building onto a safety net below. The window he jumped out from was 35 meters above the net. What force did the net apply to the man if the time between when he touched the net and when he came to a complete stop was 0.63 seconds? So essentially a man is falling straight downwards, and he's falling 35 meters. He weighs, so his initial velocity is 0 meters per second because he just jumps out of the building. He weighs 70 kilograms. And that's all we know in terms of the kinematics part. So we want to know on what speed he gets at here. We're knowing that the acceleration is negative 9.8 meters per second squared. All right? So if I want to find what his final velocity is, it's pretty simple. I use the formula Vf squared is equal to Vo squared plus 2a delta d. And his Vf squared is the unknown. The Vo squared is 0 meters per second. All that squared plus 2 times negative 9.8 meters per second squared times 35 meters. And then for Vf, if you do the calculations, is equal to, let's do it right here, negative 26.2 meters per second. And it's negative because he's going downwards, all right? You may have difficulty as to why, but it's because he's going downwards. All right, so now we need to find out how long. Okay, so he's going, so he's going at the moment he hits the net. So here's the net. At this exact moment, he is going at negative 26.2 meters per second. All right? And then how many seconds later? So at 0.63 seconds later, so let's say here, and this is 0.63 seconds later. Moments later, 0.63 seconds later, his velocity is equal to 0 meters per second. All right? So his acceleration is equal to the change in velocity, so delta v over delta t, and that's equal to 0 meters per second minus 26.2 meters per second, all that divided by 0.63 seconds. All right? And therefore the acceleration is equal to 41.6 meters per second squared. And the force applied to him from the net is therefore force is equal to mass times acceleration. And that's equal to 70 kilograms times 41.6 meters per second squared. And that's equal to 2,911 newtons. And it makes sense that it's positive because it's applying it in the upwards direction. The man is falling downwards, and the net is stopping him from falling downwards by applying a force upwards. All right, and that's my final answer. So the rest of the problems I'm going to do in a separate video. Just stand by. Thank you.